Okay, in this problem, I've got a square. It deforms as shown. Okay, D prime, B prime remains horizontal. Okay, and I want to find the strain along the AB, basically along the diagonals. Okay, and you'll remember that strain is the change in length over the original length. Okay, and for this, it's a square, so the original length, okay, is going to be the square root of 50 by 50 squared, right? Just using Pythagorean theorem on that diagonal, right? 50 squared plus 50 squared, okay? So that diagonal is 70.7 millimeters. That's the initial length of the diagonal, so I'll need that for both problems here. Now, what I need to figure out is the new distance, basically, to the dotted lines. Okay, and what I think I'll do is I'll start with CD here. Okay, so we'll go LCD. So in this guy, okay, I'm just going to use the law of cosines because I know the angle, that 91.5. I know the length of both sides, right? So it's going to be 58 squared plus 53 squared minus 2 times 58 times 53 times the cosine of 2, I'm sorry, not 2. I already have the 2. Cosine of 91.5. Okay? Doing that calculation, I get 79.6 millimeters. Plugging that in to find the strain of CD, and again, that's going to be 79.6 minus the initial, which is 70.7, divided by the initial, which is 70.7, and the strain along the CD diagonal is then going to be 0.126. And again, that's the normal strain. This one, we're not trying to find the shear strain. It's the change in length of the diagonal, essentially. So along that line, the strain is 0.126. Okay. Now drawing our attention to the AB line. Again, that's going to start at 0 and go up to this dotted line corner right there. Okay. So I need to find the length of that line that I just drew there. Okay. So what I'm going to do is I'm going to look at this triangle right here, where the length of this side is 47. Okay. And I just need to find the length of that side, which is remember, because D prime B prime is parallel, so I can find that just by taking 53, which is the length of AD prime, times the cosine of 1.5, because I know that that's what that angle is, right? It was at 90, now it's at 91.5. Okay, we get it like that. Then that becomes 52.98, which is the height of that, which is going to be the same as the height of, from A straight up to D prime. Okay. Now using that, I can just use Pythagorean theorem to find basically my new LAB, which is just going to be, again, because, this is a right angle right here. Okay, so it's going to be 47 squared plus 52.98 squared. Okay, and from that I get it to be 70.8. So this side does not stretch nearly as much as the other diagonal. Okay, plugging that in for the strain on the AB diagonal, I get 70.8 minus 70.7 divided by 70.7, and I get 0.00168. So a lot of this is just geometry. Finding an initial length, finding a final length, subtracting them, dividing, it's pretty easy stuff. It's just drawing triangles, figuring out geometry to help figure out what the new elongation of everything is.